Right. In this tutorial, we are going to look at finding the range of a function, and also we'll look at an introduction to composite functions. So when we look at the questions that are given here, we see question A reads to say, saying find the range of the following functions, and A has the function f of x being equal to x squared plus 7x. So the range of a function is just the output values which we are going to be getting from this function. So when I plug in my x, what values of y in short, so I can write this function in terms of y, then I say what values of y will I be getting when I plug in my x here. And since this is squared here and you have plus 7 here, you're always assured that for every number that you put here, whether negative or positive, this function here will always give you what? A positive value. So now you see that it will give you a positive value, and the lowest value that you can get, meaning would be what would be 0, would be when x is 0. So when we say x be 0, then we have that y is going to be equal to what? To 7. This is going to be the lowest value that we're going to get, the lowest value here. So we see if we put in negative 1, this here, when we square negative 1, this just gives us a positive 1, and this will be just 7 plus 1 plus 7, and this will be equal to what? To 8. And we see that numbers will continue going that way, meaning from what? From 7 to 8. Thus, the range of this function is going to be the set from what? 7 going all the way up to positive infinity. That would be the range for the first one there. Okay, so the second one now. So when you look at the second one, you have f of x being equal to 16 minus x squared. And now, for this one here, we see that for every value that we plug in, whether negative or positive, when we plug in where x is here, what outputs will we be getting for what? For y. So let's say I write this like this. So now, when I plug in, let's say I plug in, so the lowest value I can plug in here yet again, when I plug in, for example, when I plug in, I can plug in a negative value, but because of this square here, so if I plug in any negative value, because of the square there, I'll still get that I'll have a positive what value inside there. But now, because of that, this negative sign in between here, that means that my numbers what will be reducing. So here, if I had 1, when I square that, then I have 16 minus what? This gives me 15. So my numbers will be reducing, and they'll be what? Approaching negative what? Negative infinity. So which means the largest value I can get here is when what? When x is equal to what? X is equal to 0. And when x is equal to 0, we see that this here just becomes what? Equal to 16. And it's going to what? To negative infinity. Thus, my range for this function is just going to go from negative what? Infinity up to what? 16, because that is the highest positive value I can get out of this function. All right, so let's do the one that follows. So the one that follows now, you have a rational function, and you have the rational function, right, which is y equal to 2 over 3x minus 4. So when you're dealing with a rational function like this one, what you do to find the range of a rational function is write your function in terms of what? In terms of x. So make x a subject of the formula. Here's what we're saying. So when I cross multiply that, I just get this to be y multiplied by 3x minus 4 equal to 2. Then I can distribute this y here such that I have 3xy minus 4y, and this is equal to what? To 2. Remember, I want to write this in terms of what? In terms of x. So this will be 3xy, okay, 3xy. Then I can take that part of this function here. So I can observe, I can take the other side. This here becomes positive 4y. Then I can divide this by 3y, and the other side by what? By 3y. So now I'll have that my function is going to be what? Is going to be x equal to 2 plus 4y equal to what? 3y. So now that I have written it in terms of y, I need to just check the domain of this function. So to take the domain of this, since I've written that, that's the inverse. So now if I find, so what this is just that, if you have an inverse of a function, then when you check the domain of that inverse function, of that, function inverse, of that inverse function, you're just going to have, that would be the range of the function which we have. So if I find the same way I found the inverse of this f of x, when I check the domain of the inverse, that will be the range of this function f of x. So now when I check what this here, where it's restricted is the bottom. So I demand, or I don't want this 3. Why? I do not want this to be equal to 0, because if this is 0, then this will be undefined. So this, I do not want it to be 0, and this just simplifies, or this implies that y should not equal to 0. So if y should not equal to 0 is my domain, meaning the range as well is the range is going to be the set where y is not equal to 0. And I can write that in interval notation, going from negative infinity all the way up to 0, but 0 will not be included. So I'll open there, then I say union, then 0 all the way up to positive infinity. So that will be the range of of my function. Okay, so we do the same even for the next one that follows. It's also a rational function, and we see, I'll write it, just say y equal to x plus 1 over 2x minus 3. Then I will make x a subject here as well. So then I'll just have y multiplied by 2x minus 3 then equal to x plus 1. And this here is just going to be 2xy minus 3y equal to x plus 1. Then I can say 3y, take this negative 3y the other side and bring this x this side. I'll have negative x there equal to 3y plus 1. Then I can factor out my x here such that I have 2y minus 1 equal to 3y plus 1 divided by, so here I can divide both sides by 2y minus 1, even there 2y minus 1. So after doing that, I just end up with a function which is gonna be x equal to, so x equal to, that will be 3y plus 1 divided by 2y minus 1. And so that there is my inverse function. But then if I am just able to find the domain, that would be the range of the function f of x. So the domain here of y is just going to be all values of y except where y should not be equal to to 0 in that denominator, because that will be undefined. So then this gives me 2y equal to 1 there, then divided by 2, then I get that y should not equal to a half. So I get that 1 should not equal to half. So meaning the range of this is just going to be, so it's all values of of y defined there. So meaning to move from negative infinity all the way up to up to half, and half will not be part of that. So union again, then half, then it will go to positive infinity, and this here is going to be your range. Now the next one is a quadratic equation. So a quadratic function, I mean. So for a quadratic function, what you want to do is you want to complete the square on it such that you're able to see your maximum turning point. Then when you're able to see that maximum turning point, you see now where there the values are going to be, or are going to be defined. So if you have this function f of x being equal to 3x squared minus 6x plus 11, I want to complete the square on this. So I'll factor out a 3 there, such that I have x squared minus 2x, then plus 11 there. And this is going to be 3. Then this here, complete the square on this, then I just get x. I have this coefficient of x, that's going to be 1. then I raise that to the power 2 minus, I square 1, which is going to just give me 1. Then this will be plus 11 there. Then you get that this is just going to be 3x minus what? Minus 1 squared. Because when I distribute this 3 here, then I get 3 plus 11. And what does this give me? I get 3x minus 1 squared. Then when you add there, you just get this to be positive. Get that to be positive 8. So you get that to be positive 8. Now, what do I do from then? So what do I do from here? So from the formula, when you factorize, you know that this part here of the function, this part here, that is your x coordinate of the turning point, but you have to multiply it by a negative sign. So you get that is negative 2 over 2ab given like that. Then this 8 there is just 4ac minus that should be b squared minus 4a like that. But this is the coordinate. This is your coordinate for the turning point. So you get your x coordinate. So this negative 1, we're gonna demand that we multiply it by a negative sign so that it becomes positive 1. Then I get the 8 the way it is. And this here is the what? This is the coordinates for my turning point. So now I observe that this here, what I'm dealing with is a quadratic function. And because it's a quadratic function, I can identify that this here is my a, that's my b, and that's my c, where a is the coefficient of x squared and b is just the coefficient of x, and c is a constant there. So now from here, what you also observe is when a is greater than 0, when a is what is greater than 0, what that means is you're going to just have a turning point that is going to be facing up like that. So you have what? A turning point that is facing up. I mean, a turning point that will be like that. So you have a graph, facing up like this. So your graph will be facing up like this. Then when a is less than 0, your graph is going to face down like that. So now for us, we see that a is greater than 0. So if I was to graph this, of which I'm not going to graph in this video, you can check out another video that is already on the website on how to graph that. So now when you have it like this, we have a point where it's greater than 0. So what we know is this turning point is actually if the graph is facing like that, then I say that this turning point is at 1, is at what? 1, 8. So the x value is 1 and the y value is what? Is 8. So it's starting here. That's the highest, the lowest point now in this case. The lowest point that y can attain. So the lowest point that y can attain is what? Is actually 8. Then it's going all the way up to what? Up to positive what? Up to positive infinity, because this graph is facing up there. So meaning the range, the y values that I'll be getting are going to be from what? They are going to start from 8. And 8 is going to be included because if you plug in 8 there, it's going to be valid. So you have 8 going all the way up to what? Positive infinity. This will be what? Your range for the graph. Okay, so we take the same approach even for the one that follows next. So for the one that follows next, you have a negative instead now. So you have negative 2x squared plus 8x minus 9, and this is a function of f of x to be equal to that. Now, so you do the same thing. You factor out that negative 2 such that you remain with x squared. Then that would be negative 4x, then minus 9. And this will be negative 2. Complete the square there. Then you just get x. You have this negative 4. That would be negative 2. Then you square this negative 2. That would be minus. Then you square the negative 2, you get 4. Then you have minus 9 there. Then you can distribute this negative, then you get, that will be negative 2 in front, then x minus 2 squared. Negative by negative gives you a positive, and you get positive 8 minus 9, and this just gives you negative 2 x minus 2 squared, then this will give you minus 9 there. So now we do the same analogy of saying that if a is greater than 0, then this is going to face up. If a is less than 0, then the graph is going to face down. So if the graph faces down, it means you have a maximum turning point. You have a maximum turning point. So in our case, we see that our a, if we take our here, this is our A, that's our B, and that's our C. Our A is actually less than, so meaning we have a maximum turning point there. So now, what we ought to do is to get the coordinates, we get this part here multiplied by that negative such that we have a positive 2, then we get this negative 1 just the way it is. So like that. So this here is going to be what? Is going to be our turning point. So if you graph this, or if you plot this, you're going to plot your maximum turning point at 2 comma negative 1. So now negative 1, that's your y value. This is your x comma y. That's your y value. So meaning this is because this graph is facing down, meaning the value is going here, down there, going all the way, are going to be reducing. So this means that negative 1 is actually the highest y value that you can attain as you be plugging in your values in there. So which means your values are gonna range, just gonna range from what? Negative 1, and that's gonna be included. No, 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 no. We have to write that differently. So we're saying since you get values lower there, meaning from negative infinity, and the highest y value you're gonna get is what is negative 1. So negative infinity to what? Negative 1, and to be close there. And this here is gonna be your range for that for that function. Yeah, so this is how you just compute and work around the function for these kind of functions given here. Uh, yeah, we'll move on and just get a brief introduction to, or just answering a few questions on composite functions. So we have these questions here, and saying if f of x is equal to 2x minus this is minus 3x plus 1, then g of x is equal to 3x 1 plus 1, and h of x is just equal to, can I see that clearly? So I'm gonna pull this a bit down. So that is just equal to root of x squared minus 4x. Then they're telling me to find these here. So the first one, they're telling me to actually find g of, f of g of what? Of x. So to get this, what this just actually means is, so this implies f, then in the function of x, f, I'm actually replacing, where there's x, I will be replacing what? The function g of x this time, like this. So meaning, so let me write, so writing down my function f, so my function f, okay, my function f here is given there, which is, so the function is 2x squared minus 3x plus 1. That's my function for f. But then what I have to do is in that function, in this function, where there's x, I must replace the function what? G of x, which is that there. So I have 2, then here I will replace 3x plus 1, then I square that, then minus 3, then there I replace again the 3x plus 1, and then I have a plus 1 there. So this just is gonna give me, so I can then this here expand this. So when I expand that, I have a 3x plus 1. So 3x plus, so this will be 3x multiplied by 3x, which is gonna give me 9x squared. Then I have a 3. Okay, you work that out and just get a positive 6x here. Then you get a positive 1 there. Okay, so that's expanding this. Then you have, I'll write this again, just 3x plus 1, then plus 1. Okay, then from there, I can distribute this 2 inside there, such that I have, that will be 18x squared. Then I just get out there with a 12x, then plus 2. I distribute that there, I just have negative 9x. Then there gives me a negative 3 plus 1. Then what do I get if I continue evaluating this. I write this in yellow. So this, then I can subtract this part with that part. That gives me, so 9 minus 3 gives me 3. So I write the 18x squared first, then that gives me 3. So that I get a positive 3x. Then I'm saying this, I add there, this gives me negative 2, but negative 2 minus that 2 there, negative 2 minus that 2 there, and I get a 0. So I just end up with the final answer being 18x squared plus 3x. So that is the function g or f of g of x. Okay, B then demands me to evaluate x. Now I have a value. The value of x is just what is negative 2. So how do I do that? So well, this function that I'm just from finding is not going anywhere. I have to work with that really. So you have f of g of, so where there's that, it's the negative 2 now. So means in this function of which we've already found it, where there's x, just replace the negative 2 and you get negative 2 there squared plus 3 negative 2. And this here just gives you 18 multiplied. So this will be 4, positive 4. Then there you just, here you get negative 6. Okay, so what do we get when we multiply 18 by 4, and that just gives us 72 minus 6, and that just gives you 66. So this here is equal to what? 66. That's what that value is. Okay, move on. Let's do the other one. So now, this time we start with g of f of x. So that's what we are finding. So this is just saying g. So in the function g, where it's x, just replace the function f of x. And this is gonna be, so the function g is 3x plus 1 given there. So where there's x, I'm gonna replace the function what? F of x, which is 3, which is given as 2x cubed squared, minus 3x plus 1, then I have a plus 1 outside there. And this here, when I multiply, I just get a 6x squared. Then I have a negative 9x. Then I have a plus 3 plus 1. And I can simplify this to just x squared, then minus 9 squared plus 4. And this here is my function that I demand to have. Next, I focus on f. So f of h of x. So what is this? So this is just f, then h of x. And I'm sure by now you get how this kind of works. So in the function f, which is there, where there's x, I replace this function, which is h. So 2, then that function is going to be root of x squared minus 4x. Then there's a square there, minus 3. So where there's x, root x squared minus 4x. Then I just have a plus 1 outside there. So because of this squared, squared and this square will cancel out and have a 2 multiplying with whatever remains inside there. And that will just be 2x squared. Then I have a minus 8x. Okay, good. Then I multiply this 3 multiplied by that. So it'll be 3 multiplied by the root of x squared minus 4x. Then, okay, I have a plus 1 there. So I can't really simplify this further on, so I just rather end here. Okay, so that is gonna be that one. Then we have this one here. We have that one there. So how do we do that one? So with that one, they're just telling you to say, find h of g, but it has to be evaluated at 3. So my function h, it's like I'm plugging in what? 3 there, x, like that. I mean g of x. Then it's evaluated at what? At 3. So function there is at root. Then what is x? I plug in my function. So I have to plug in my function, but my function has to be evaluated at 3. So in the function g, I'm plugging in that 3 there. So in short, I'm evaluating that at where there's 3, I'm gonna have 3 multiplied by 3 plus 1. This is gonna be 9 by 9, and I have a 10 there. So what this means is I'm just replacing 10 there, and you have a 10 there. So 10 where there's x squared, you have a 10. So this is gonna be 10. Hope this is right. Does this look right? Right. Yes, so I have a 10 squared minus, then you have 4 multiplied by 10 as well. And this gives you something like, so you get 100 minus 40, and 100 minus 40 just gives us root of, this is gonna be root of 60. Root of 60. Okay. So question is, can I simplify that further on? Yes, I can. So 60 is divisible by 4, which is like 4 is a perfect root, square root. So I'm just gonna say this here, 60, is just gonna be the same as saying if I multiply 4 by 15, I get 60. And I can write this separately as root of 4, root of 15, and this just simplifies to 2 root 15. And that there is gonna be my, that's gonna be my value there for question E. Okay, we move on to the last question for this video, and that question just requires us to find h of h and x. So that's gonna be h, then g of x. So it's g of x. So what is h? So h is given there, here in the question, which is just like root of x squared minus 4x. Then you have to, where there's x, replace it with the function g. So g is, so I'll go ahead and say 3x plus 1. Then I square that. Yes. Then minus 4. Then I have there 3x plus 1. Then what I'm gonna have here, I can expand this first part, meaning that would be 9x squared plus 6x plus 1. Then multiply this, then you get 4, no, you get 12x. So you get 12x, then you get negative 4 there. Yeah, then from here, then our value is just gonna be equal to, use another color there. So this is gonna be, so you have 9x squared, subtract these here, you get a negative 6x. You then add your 1 to this negative 4, then that gives you negative 3. And this here becomes your h of g of x. And that's our final answer. And that's all for this video. If you're new to this channel, remember to hit the subscribe button and like and share for more content. Otherwise, we'll see you in the next video.